This is the video for section 5.2 notes, slides 11 and 12. All right, so it says use the velocity graph to the right. All right, so this is a graph of velocity versus time. All right, when is the object moving forward? All right, so remember, moving forward, right? That would mean that distance or displacement is increasing, so velocity must be positive. So wherever this graph is positive, all right, so from 0 to 1, and then from 5 to 8. All right, so remember, whenever v is greater than 0. All right, when is the object moving backward? Obviously, whenever v is less than 0, right? And so that would be just from 1 to 5. All right, so that's pretty simple, just evaluating this graph. Now, when is the object speeding up? All right, so what does speeding up mean once again? Remember, okay, velocity and acceleration have the same sign. All right. So when velocity and acceleration have the same sign. All right. So let's take a look at this. All right. So this first section here from 0 to 2, you see that velocity is above the x-axis. So v is greater than 0, but it is decreasing. So that means acceleration is less than 0. Okay. Now during this next section from 1 to 2, okay, velocity is now less than 0 because it's below the x-axis, and this function is still decreasing. So acceleration is less than 0. So that means they have the same sign. So that would mean that the object is speeding up from 1 to 2. All right, now what about during this next section here from 2 to 5? All right, velocity is still below the x-axis, so it is less than 0, but now velocity is increasing, and so acceleration is greater than 0. So they have the opposite sign. All right, now what about from 5 to 6? All right, velocity is above the x-axis, so it is greater than 0, and acceleration, well, is positive because velocity is increasing, and so a is greater than 0, so they have the same sign, and so from 5 to 6, the object is speeding up. All right, what about from 6 to 7? So velocity is greater than 0, right? Because this is above the x-axis, but acceleration is equal to 0, right? Because the derivative, the slope of this is 0, right? And you would say velocity is constant. All right, and then the last from 7 to 8, all right, velocity is still above the x-axis, so velocity is greater than 0, but now velocity is decreasing, so acceleration is less than 0. All right, so now when is the object slowing down? Well, remember that means that v and a have opposite signs. And we already did that work. All right, so V and A have opposite signs. So where do they have opposite signs? Well, V is positive, A is negative from 0 to 1. All right, both negative here. V is negative, A is positive here from 2 to 5. And then lastly, from 7 to 8. All right. Now, it's important that you think. All right. When would an object be speeding up and when it would be slowing down? Well, remember, the object is stopped whenever the velocity is 0. So think about this. Okay. If you're going to stop, what do you have to do before you stop? You have to slow down, right? So it's slowing down from 0 to 1. All right. Then after it's stopped, you have to speed up, right? So from 1 to 2. Then before it stops at 5, you must be slowing down. And then after it stops, you must be speeding up. And then before it stops at 8, you must be slowing down. So that is always helpful in thinking about speeding up, slowing down. All right, when does the object attain its greatest speed? So remember, speed is the absolute value of velocity, right? And so when is this thing furthest from 0? Well, it's furthest from 0 here at t equals 2, and it's furthest from here as well, but that's kind of an endpoint, so you might not necessarily uh, include that. So t equals 2, or maybe, okay, you might say and or at t equals 0, depending on how you argue whether or not that endpoint should be included. All right, so that's slide 11. All right, moving on. Use the velocity graph to the right, graph speed versus time. So remember, okay, the speed is just the absolute value of velocity. So any part of velocity that is negative just needs to get flipped up. So speed, right, retains the part that's positive, and then the negative part just gets flipped up, right? And so that part gets flipped above the x-axis, and then the other parts still remain. So pretty easy. Now, if you look at this graph, is it pretty easy to see, like we talked about in uh, s- uh, problem 10 and 11? is it pretty easy to see that speed is that we're slowing down from 0 to 1 and from 2 to 5 and from 7 to 8, right? And then we're speeding up from 1 to 2 and from 5 to 6, right? It's really easy to see when you look at the speed graph. All right, but that is slide number 12.